It's a clear, frosty morning here in the Upper Ottawa Valley, but even on a cold morning like this, the sun is flooding the forest with energy. The Earth's tilt this time of year reduces the energy falling on horizontal surfaces, but an object at right angles to the sun's rays is receiving approximately 1,000 joules of energy per second per square meter. That means that each square meter receives power at the rate of 1,000 watts. That is a lot of power. Let's see if we can capture some of it. This device in my hand is a photovoltaic cell. The crystal structure of this high-tech piece of equipment is designed to produce electricity when light, particularly sunlight, shines on it. Let's take a look at how these things work. If you have watched our video on electricity, you will know that electricity is a flow of electrons, charged atomic particles, that travel through a conductor from the negative terminal to the positive terminal of a battery. The battery is a chemical device that produces the force needed to move the electrons. In this animation, electrons are flowing through a light bulb. Electrical energy is being converted to light energy. A solar cell acts much like a battery cell. When light shines on the surface, energy is picked up by electrons. They use this energy to move from the negative terminal of the cell through a circuit to the positive terminal of the cell. Solar cell manufacturers use silicon crystals to create solar cells. Silicon is a very common element. If you have ever found a piece of quartz, you have found a crystal created from silicon and oxygen. A silicon atom has 4 valence electrons. This simplified model shows a silicon crystal structure, with each silicon atom connected to 4 others. It turns out that elements like phosphorus and boron can be added to silicon, creating crystals that form the negative and positive layers of a photovoltaic cell. The negative, or N layer of the cell, is created when a phosphorus atom, which has 5 valence electrons, replaces a silicon atom. The 5th electron of the phosphorus atom is weakly bound to the atom. If this electron picks up some energy, it can move and become electricity. That energy can come from light. Similarly, the positive, or P layer, is created when a boron atom with 3 valence electrons replaces a silicon atom. This leaves a positive hole and creates a positive layer that attracts electrons. In a complete solar cell, the N and P layers are sandwiched together. The movement of electrons in this configuration is complex, but basically light energizes electrons in the N layer, and they are attracted through a conductor to the positive P layer. This is electricity. This iridescent blue side is the negative layer of this cell. The thin metal bars embedded in the surface provide a conductive path for the electrons. This cell has a black wire connected to the metal bars. This is the negative terminal. The positive terminal is the back of the cell. It is covered in a metallic sheet. Connecting the negative probe of a voltmeter to the black lead and then touching the positive probe to the back of the cell, we get an open circuit voltage reading. A single cell like this will produce 0.5 volts in direct sunlight. Today, the sun shining through an open door is giving us between 0.45 and 0.48 volts. The short circuit current output of a cell this size is small. Today I'm getting less than 50 milliamps. To produce higher voltages and currents, it is necessary to connect multiple cells in series and parallel. The large cells used in commercial installations are created by assembling multiple single cells into a panel. As I mentioned at the beginning, the sun floods the Earth with about 1,000 watts of power per square meter. Commonly available solar cells convert about 10% of this energy into electricity. but researchers are currently working on a new generation of solar cells capable of converting over 40% of the sun's energy to electricity. This exciting green technology will soon be contributing significantly to our power needs. To learn more about electricity and energy from the sun, visit our website, hylaroad.com.